Okay, I'm going to be working the solutions to Chapter 10, Section 1 here, and working out of the book, starting with number 2. I'm supposed to sketch some points on a single set of coordinate axes. So give me, let's see, the point 0, 5, 2, the point 4, 0, negative 1, the point 2, 4, 6, and the point 1, negative 1, 2. All right, so I want to put these all on one three-dimensional picture. Let's see if I don't think I have a ruler in here. Nope, I don't. So I'm going to start out here by first drawing myself a decent three-dimensional, or a two-dimensional representation of three-dimensional space. So start out by drawing this kind of flattened out X that crosses through this vertical line. And this is going to be my X positive, my Y positive here, and my Z positive here. And I'm following the right-hand rule here. So my fingers are curling from the X positive towards the Y positive. My thumb is pointed up, Z positive. So let's first start out with this point 0 is the X coordinate, the Y coordinate is 5, the Z coordinate is 2. So that means I start at the origin. On the X axis, I don't move. On the Y axis, I move 5 units in the positive direction, which would be this direction. So 1, 2, 3, 4, let's say that's 5 there. And then from there, I go up 2 units. So let's see if this is, let's say, 1 unit and this is 2 units. Then what I would do is I would kind of measure out what 2 units is, and then straight up from here, I would go that 2 units and I would put a dot. And you can kind of see it here if I were to connect this with a dotted line straight up, and then I draw a line coming over like this, dotted. Remember that any lines running this way have to be parallel to the x-axis. So it's almost like I took this line segment and just moved it straight up. So there's the first point. I'll call this point A. So here's A. B, I'm going to move out 4 on the x-axis in the positive direction. So 1, 2, 3, here's 4. On the y-axis, I do not move, so I'm not going to move this way. And then I'm going to go down 1. So let's say this is negative 1. So again, I kind of measure that out. And I come over here, move down 1. And that will be my second point, which I'll call B. So this is B. Again, you can see if I connect this dotted line, then I come over like this. Remember, any lines going this way must run parallel to the x-axis. So that's the other point. Now I'm going to have too many crazy dotted lines in here, so I'm going to just take these out. I'll leave that one. Okay, next one, 2, 4, 6. So on the x-axis, I move out 2. Then on the y-axis, 4. So let's see, 1, 2, 3, 4 is here. So whatever that distance is, starting from x being 2, I need to run that distance, which is here, running parallel to the y-axis. So I'm going to be about right there. And then from there, I need to go up 6. So if this is 1, 2, here's 3, 4, 5, 6. I'm going to have to measure that out. Let's see if this is long enough. Nope. So let me get something else here. Let's see. Something like this. So from that point, I go up 6. It should put me about right there. That'll be C. And then D, I go on the x-axis 1, y-axis negative 1. So negative 1 is this way. So I'm going to go, that distance over, imagine just kind of like parallel out here to here. and then up 2, so we know this is 2, measure it out. 2 is going to put me about right here. Okay, so that's D. I'll take this dotted out. That's it. Those are the 4 points on one coordinate axis there. Okay, let's move on to the next problem, which is number 3, and it gives you some points and then asks you some questions. So let me write out what these points are first. So on number 3 gives you the points. A, they do it this way. A is the point -4, 0, -1. And then the point B is the point 3, 1, -5. And the point C is the point 2, 4, 6. And the first question is, which of these points is closest to the YZ plane? So the YZ plane, what's the YZ plane? Well, here's X positive, Y positive, here's Z positive. So the YZ plane is the plane that contains the Y-axis and the Z-axis. So if I imagine coming in here and drawing a sheet, that's not what I wanted. Like this. Okay, it's this flat sheet right here. And I have the x-axis punching out of the sheet and the x-axis going backwards behind the sheet. And it's saying which of those points is closest to it. Well, let's see. The first one, x is -4, y is 0, and z is -1. If I do that point real quick, x is -4 takes me back 4. Then I don't move left to right for the y-axis, and then I go down 1. Okay. So if I were to kind of look from the side, this is going to be difficult to show. I have the plane here. I have that x-axis coming out like this. So I'm looking at it from this side right here. I actually had to come back on the x-axis 4. So I went back on the x-axis 1, 2, 3, 4. And then on the z, I came down 1. So I would actually have come down 1 like this. So you can see that the distance from that point to that plane is actually, in terms of a distance, it's 4 units. So that's how far away that point is. Now, if I look at this one, I go on the x-axis 3, 1, 2, 3. Then I go to the right on the y-axis 1, which puts me about here, and then down 5, okay, which puts me somewhere in there. So again, if I look at it from the side, I came out on the x-axis 1, 2, 3, and then when I came this way, that would actually be coming towards me, and then I went down 5, which would put me down here. So you can see that the distance between that point and that point would be, or that point and that plane would be 3. So there's something happening here. We're getting, this value is actually telling us how far we are away. If we take the absolute value of -4, we get 4. Take the absolute value of 3, well, we still get 3. So maybe that's all we have to look at, just the x-coordinates. Let's do it one more time with this C. With C, we go on the x-axis 2, then the y-axis 4, which brings me over, see, we'd have to measure it 1, 2, 3, 4, so whatever that distance is, running parallel, I'd come out here, I'd be somewhere around here, and then I go up 6, which would be, I don't know, somewhere up here. So if I'm going to look at it, if I'm going to look at that, let me connect these. Came out to here, like that. Oh, it's supposed to be straight up and down. If I were to come in and look at it from the side, I had to come out on the x-axis 2, and then again towards me 4, and then up 6. So the point from the side would be somewhere up here, and that distance would only be 2. So what's dictating the distance from from the point to the YZ plane is the absolute value of the X coordinate. So whichever of these is the absolute value, whichever absolute value is smallest would correspond to the point that's closest. I think that's what they wanted. Yeah, closest to it. So which one's closest? The point C. All right? I hope that makes sense. This would be your answer. Now the second part of this says, which point lies in the XZ plane? So which of these points lies in the XZ plane? Well, let me draw an XZ plane. We'll try and draw it up here. Let's see if I have another marker. I don't know if this one's going to work. Yeah, it's good enough. The XZ plane looks like this. So it contains the x-axis and the z-axis. So all the points that are on that plane, you can't come off the x-axis or the z-axis. You can't come off those lines. Well, you could be, yes, you could come off the lines, but you can't move out on the y-axis at all, or else you'll be off this green plane. So in order to be on the xz plane, your y-coordinate must be 0. And in fact, that is the definition. This is the xz plane. The equation y equals 0 defines, in three-dimensional space, defines the xz plane. So the only point that's going to lie on that xz plane is the point that has a y-coordinate of 0, which is this one. Okay, so A is the one that lies on the xz plane. I believe that's it for number 3. Let's move on to number 7. For number 7, find the lengths of the sides of the triangle PQR. So they're giving us a triangle. We're calling it PQR. Find the lengths of the sides. Then they ask, is that a right triangle? And then, is that an isosceles triangle? So there's actually 2 parts to this problem. So part A gives you one point P, which they're defining to be 3, -2, -3. Then they give you Q, which is the point 7, 0, 1. And then they give you R, which is the point 1, 2, 1. All right. So we could draw this. I think I'll do it. Let's see if I can do it quickly. It's not asking you to draw it, okay? P, the point P, I go out 3, 1, 2, 3 on the X, -2 on the Y, 1, 2 on the Y running parallel, and then -3, 1, 2, 3, 3 straight down. So there's 1 point. That's P. And then Q, I come out 7 on X, 1, 2, 3, 4, 5, 6, 7 on X. I don't move left or right on the y-axis. I move up 1 on the z. So this is Q. And then R, I come out on the x-axis 1. I go, let's see, 2 units on the y-axis. So 1, let's say 2, then up 1, which is somewhere around there. Now if I connect these together, PQR, I have a triangle in 3-dimensional space. It looks like it's laying flat, but it's not. It's the problem with trying to draw a 3-dimensional space on a flat sheet of paper. Things don't always look the way that they really appear. All right, so the thing is, find the lengths of the sides of this triangle. So let's try and find the lengths of the sides of this triangle. So let's first find the length of, let's go PQ. So what is the distance from P to Q? Well, the distance from P to Q, we can just use a distance formula. It'll be for, let's say, the length of PQ is going to be the difference of the coordinates, the square of each of those, and then the square root. So let's start, let's go 3 minus 7, which is negative 4. It's a difference of the x coordinates. Negative 2 minus 0 is still negative 2. And then negative 3 minus 1 is negative 4. And if I clean this up, we have square root. We have, what, 16? 16 here again. When we square these, that's 32. And then plus 4 is 36. So we get 6. So this distance from P to Q is 6. Now let's look at the distance from Q to R. Distance from Q to R is going to be the square root of, all right, Q to R. So I'm going to go 7 minus 1, which is 6 squared, plus 0 minus 2 is negative 2 squared, plus 1 minus 1, which is 0, and then squared. So we get 36 plus 4 is 40, so square root of 40. I'll just leave it like that. So this is root 40. And then we're going to go the distance from, let's say, P to R. So the distance from P to R will be, we're working, forget this one, here minus here. So we have 3 minus 1 is 2, 2 squared, plus negative 2 minus 2, negative 4 squared, negative 3 minus 1, negative 4 squared. So we get, what, 4. I think this looks similar to this one right here. So this should just be 6 again. Here we go. All right, so let's answer the first part of this. We figured out what the lengths of each side are. Is this a right triangle? Well, let me try and draw that triangle as if we were looking at it. That's not drawn very good. 6, 6, root 40. Question is this a right triangle? Well, if it's a right triangle, it has to follow Pythagorean identity, or Pythagorean theorem, which says that a squared plus b squared is c squared. We know this is the hypotenuse. The reason we know that is because the square root of 40 is definitely bigger than the square root of, the square root of 36, which is 6. So that's the biggest side. And so I'm going to check. Is 6 squared plus 6 squared equal to the square root of 40 squared? So 6 squared is 36. 36. What's that? 72. Is that equal to square root of 40 squared? No, it's not. So that is definitely not a right triangle. Is it an isosceles triangle? Hold on just a second. Oh, hold on, I'm getting a quick text here. All right, so we know that it is not a right triangle. So was that part A? No, that wasn't part A. I'm just supposed to answer the question. So it's not a right triangle. And then, is it an isosceles triangle? Well, to be isosceles, you just, excuse me, you just need two sides to be equal, which it is. All right. Oh, I thought that didn't look right. Isosceles. So now the next problem, the next part B, I'll let you do on your own. Since I showed you how to do this, they give you 3 different points, and I'll just let you know it does turn out to be a right triangle. So when you do the Pythagorean on it, it's going to work. Okay, let's look at number 8. Find the distance from this point 4, -2, 6. Find the distance from that to A, the xy plane, B, the xz plane, C, yz plane, then xz plane, D, x-axis, E, y-axis, F, z-axis. All right, let me try and do this. Okay, 4, -2, so that many units run it parallel here, and then up 6, which I'm going to say is about here, so 1, 2, 3, 4, 5, 6. Here we go. So we have this point to get out there. Okay, there's our point. So what is its distance? You know, I can do this to show you. I don't know if that helps you see where it is. So what's the distance from this to the xy plane? Well, the xy plane is the ground, right? This is x, this is y. So it's the distance from this point to xy plane is the distance from this to the equation z equals 0. So you're just looking for the distance from that point down to the ground, which was 6. To the yz plane, you're looking at the y-axis and z-axis. You're trying to look at the x-coordinate, just like we did in the previous problems, one of the previous problems. So we're looking at the distance from here to here, which was 1, 2, 3, 4, right? So 4. And the distance to the xz plane, which is this sheet here. So we're looking at how far away the y-coordinate is, and that was 2. And then here's where things get a little tricky. I want to know distance shortest distance between that point and the x-axis. Well, the x-axis is running here. So imagine right here we went out 2, we went up 6. We want to know the shortest distance back to the x-axis. So if we connect straight down here to this point, then what we've created here is like a little right triangle. And we're trying to find the distance of that red piece. We know that this side is 6, right? From here to here is 6. We know this distance from here to here was 2. And we're trying to find this side right there. So Pythagorean, we'll call this h for hypotenuse. We know 2 squared plus 6 squared is 8 squared. So 4, 36, so root 40 is h. So that's your distance. And then the distance between the y-axis, that short distance between that point And the y-axis, well now here's your y-axis. So we want to connect a line going from that point straight down to the y-axis, shortest point, which would go to this point right here. So just on the y-axis, move 2 over. And that creates this right triangle. See if you can see that kind of coming out at us, up, back down. So if we draw that triangle, we know this distance right here was 6. Distance from here to here was 4. And so this side h we could solve for. 6 squared plus 4 squared equals h squared. So 36 plus 16, what's that? I can't do simple math right now. 36 plus 16, 40, 52. So root 52 is h. All right, now to the z-axis. This one's a little harder to see, I think. I don't like this dotted line. Let me move it up a little. There we go. Okay, so here's our z-axis. The shortest distance from that point to here, let me see if I have blue in here. Oh, I do. Would be the distance from that point to here. And so we create this right triangle right there. It's kind of laying flat. And so if I draw that triangle, I'll draw it this way. You know that that's a right angle. So this distance from here to here was 4. And we know the distance from here to here was 2. Call this h. So h squared equals that squared 16 plus that squared, which is 4. So root 20. That's it. I like that problem. Where are we at here? Number 11. Find the equation of the sphere that passes through this point. And, hold on, there's more. And has a center that's given. So for 11, you're given a point on the sphere. The point that you're given is 4, 3, -1. And you're given a center of 3, 8, 1. It says find the equation. So we have a nice equation for spheres. X minus h squared plus y minus k squared plus z minus l squared equals r squared. Make sure that's coming out on the camera. Yeah. HKL is always the center of the sphere, which we're given. That's nice. HKL. Now, did I use HKL or RST? Yeah, HKL. And then the point we'll deal with in a second. Let's just rewrite this. So far, we have x minus 3 squared plus y minus 8 squared plus z minus 1 squared equals r squared. That's the equation of the sphere so far. All we need to do is figure out what r is and we're done. We have the equation. That's where the other point comes in. We know that when we actually plug this in, right, this for x and then for y and then for z, that this equation must be true. So let's try and plug in. So using the point right now, 4, 3, -1, we get this equation to turn into 4 minus 3 squared plus 3 minus 8 squared plus, let's see, negative 1 minus 1 squared must equal r squared. So I'm just replacing the x, the y, and the z with that point. And now the only variable left here is r, so we can solve for it. So we get, let's see, 1 squared is 1 plus, let's see, this is negative 5 squared is 25 plus, this is negative 2 squared, which is 4, equals r squared. And so we get, what do we have, 25, 30. 30 equals r squared. So all I have to do now is go back up to this equation and replace r squared with 30. So we know that the radius of this thing is actually the square root of 30, right? Because r squared is 30, so r is root 30. But in the formula, we put r squared. So this is the equation of the sphere that passes through this point. So that point lives on the surface of the sphere, and this is the center of the sphere. Number 13. This is kind of backwards now. They give you the equation, then they ask you some information. They ask you to figure out what its center is and what its radius is. So here's the equation of the sphere. X squared plus y squared plus z squared minus 2x minus 4y plus 8z equals 15. What we need to do is we need to turn this into x minus h squared plus y minus k squared plus z minus l squared equals r squared. We need to turn it into that. If we can do that, then we'll be able to find what they want, because they want to know what the center in the radius is. So we need to find HKL and R. So this looks like a big mess right now, but what we're going to do is we're going to take this and we're going to complete the square on both x, y, and z to turn this into these three pieces. So I will first group my x terms together, then my y terms together, then my z terms together, and then I will complete the square on three different variables. So I'm going to complete the square on x, complete the square on y, complete the square on z. So the method for this, remember, is to look at the number in front of the variable that's not being squared, so the number in front of x, the coefficient. We take half of that, we square it, and then we add and subtract that. So I'm going to take half of negative 2, I'm going to take half of it, which is just negative 1. I'm going to take that answer and I'm going to square it, which is 1. And so what I'll do is I will rewrite this, x squared minus 2x. I will now take this number right here, I will add it, and I will subtract it, because that's really our hidden 0. And then I do the same thing for y, plus y squared minus 4y. I take the number in the middle, negative 4, divide by 2 is negative 2. I square it, which is 4, so I'm going to add and subtract 4. Okay, same thing here, plus z squared plus 8z. Half of 8 is 4. 4 squared is 16. I'm going to add and subtract 16. And then we still have equals 15. Now, if you do this correctly, which I think we have, then the first three terms on each of the variables here, these three, those three, those three, are perfect square trinomials. So they will turn from this into something like this. So I'll have x minus 1 squared. I still have minus 1, plus these three, which is going to be x minus 2 squared. Then I still have minus 4. And then this one is going to turn into z plus 4 squared. And I still had minus 16 equals 15. And then I just put these together on the left side, these numbers here. So negative 1 and negative 4 is negative 5. Negative 5 minus 16 is negative 21. So I have a negative 21 on the left side. I'll add it to both sides. So I'm adding 21 here. I'm adding 21 on this side. I'm going to get 36 on the right side, and then all those constants are going to be gone on the left side. So what I will get is the x minus 1 squared plus the y minus 2 squared, and then plus the z plus 4 squared. And we said when we added 21 over here, we got 36. And so now it's very obvious what h, k, and l are. The center of this is the point HKL, which for us is, remember the minus here, be careful, it's 1, the opposite of this, 2, the opposite of this, negative 4, and then the radius is equal to the square root of that number, which is 6. So we have completed the square several times there in order to recover the equation of the sphere in a format that allows us to identify the center and the radius easily. All right, so 15 is also a completing the square problem. It's going to get a little ugly though. I think I'll do it because it's a little uglier. How are we doing on time here? 38 minutes in. So for 15, 2x squared plus 2y squared plus 2z squared equals 8x minus 24z plus 1. All right, so we're told this is a sphere. We need to just get the center and the radius. So I'll move all the stuff to this side, all the variable stuff to the left side. I'll leave that 1 over here. I'm going to group the x's together. So 2x squared minus 8x plus 2y squared plus 2z squared. Okay, so I don't have any y's to bring over. The negative 24z comes over here as positive 24z, and then equals 1. All right, now I'm going to group these two. The y's, these are the only y's I have in them, those are the z's. So when I complete the square, I'm only going to need to complete the square on the x and the z's. The y already is completed the square. There's no y term by itself. So over here, before I can complete the square, I have to pull a 2 out. Here, 2y squared. Before I can complete the square, I have to have a coefficient of 1 there. So I pull a 2 out. That's what I did on the x also. Okay, that's where things get a little bit tricky. When I complete the square here, I'm doing it on this and on this. And so what I'll do is I'll rewrite this to parenthesis. I'm going to take half of negative 4, which is negative 2. I'm going to square it, which is going to give me 4. I'm going to add and subtract 4, but watch where I do it. Right here, inside that parentheses, add 4, subtract 4. Inside that parentheses. If you don't do that, you're going to get yourself in trouble. 2y squared plus 2z squared plus 12z. Okay, half of 12 is 6. Squared is 36. I'm going to add and subtract 36. Inside that parentheses, and then equals 1. Now, when I do this, the first 3 terms in there, right here, and the first 3 terms here will form a perfect square trinomial. So we're going to, or is a perfect square trinomial. And so I have 2, then I have a parentheses. Now be careful here. This forms another set of parentheses, x minus 2 squared. So that's this blue part. Then we still have minus 4. Then we have plus 2y squared plus 2. And then over here, these 3 form another parentheses, z plus 6 squared, but I still had a minus 36 equals 1. Now I'm going to distribute that 2 and that 2 through these parentheses. Let's see what we get. So 2 multiplied to this big chunk is just 2x minus 2 squared, and then 2 times negative 4 gives me negative 8. And I'm done with that, so plus 2y squared. And then the 2 through here and here, so plus 2, and then in parentheses z plus 6 squared, and then 2 times negative 36, negative 72, and then equals 1. So now what I'll do is I will get my constants together here and take them to the other side. That's negative 80. And so I'm going to add 80 to both sides. And when I do that, I get 2x minus 2 squared plus 2y squared plus 2z plus 6 squared. My negative 80 add 80 to both sides, we get equals 81. And then this almost looks right, except I've got 2's in front of these things. So I'm going to divide everything by 2. Divide this by 2, divide this by 2, divide this by 2, divide this by 2, and we will have the following. X minus 2 squared plus y squared plus z plus 6 squared equals 81 halves. And that looks like what we need it to look like. Keep in mind that this right here is really y minus 0 squared. So the center of this sphere is positive 2, 0, negative 6. And the radius is the square root of that, which is 9 over root 2, which you could rationalize if you want. You could write 9 root 2 over 2. I'm going to check this one. Seems kind of weird for the radius, but yeah, that's right. Okay. All right. Let's see, number 15. Number 19 is next. For 19, they give you that you have a sphere, the center of the sphere is 2, negative 3, 6. And let's see, part A, xy plane. For B, the yz plane. And for C, the xz plane. And what they want you to do is they want you to find the equation of the sphere that has this center but just touches this plane. And then do it again for just touching this plane and then touching that plane. So I'm only going to do part A. So what I'll do first is I will draw out the center and put that out here. 1, 2 on the x-axis, negative 3, so somewhere around here. That doesn't look right. And then up 6, somewhere up there. All right, so there's the point. And we want to find, that's the center of the sphere, but it's just going to touch the xy plane. So if that's the center and I draw a sphere around it and I want that sphere to just touch the ground, then the closest point from the center to the ground is this point right here. So imagine the sphere goes like this. It's going to be bad because I'm going to go off camera. Okay, and it's going to be something like this, right? With the bottom of it just touching this. So look, for the equation of a sphere, we only need two things, a center and a radius. This is the center. We have that. All we need is the radius. And we can tell here that the distance from here to here would be our radius, and that is given to us to be 6. So the equation is pretty simple to come up with. It's x minus 2 squared using the center, plus y plus 3 squared, plus z minus 6 squared, equals the radius, which we said is 6, squared. So that's the answer to part A. Then you do the similar thing for the YZ plane. What you're trying to do is touch this wall here. So let me do it this way. Okay, so there's our point. So we want to know the distance from here to here would be the radius of that sphere. That sphere would be something like, that's a point on the sphere. This might be a little harder for me to do. Boy, that's hard to do. But no, this is the radius, so it's got to touch that. So something like that. It's bad drawing. I shouldn't have done it. But the important thing is that distance from the center to the YZ plane is just the distance on the x-axis, which would have been 2. So you just replace that with 2 squared. All right, that's it for that. What's left? $21. For 21, it says describe in words. Uh-oh. All right, so 21. So describe in words the region in three-dimensional space represented by the equation or inequality. So for 21, gives you x is 5. So x is 5, what is that in three-dimensional space? Well, it's a plane, okay? It's parallel to the YZ plane. So I'll draw a quick picture of this. X is 5. It's every point that has an x coordinate of 5. So we imagine there's like this plane here. It's the YZ plane, but it's been moved out 5 units on the x-axis. So it's obviously parallel to the YZ plane. $23, y is less than 8. Okay, so if it said y was equal to 8, it would be a plane, wouldn't it? It said y is equal to 8, and it would be on the y-axis. So it would be something like, here's 8. It would just be this plane, like this. So it's like the xz plane, but moved out 8. That's not what we're saying. We're saying all y values are less than 8. So it's actually everything to the left of this plane forever. So what do we call that? It's almost like a solid, but you can't say it's a box because it goes up forever and up forever, down forever, in these directions forever. So it's everything over there. So we call this a half space. It's part of the entire three-dimensional space. I know technically it's not half of it, but that's what we call it. It's a half space. It's almost like you cut the number line here, 0. You want to say everything to the left of 8, not including 8. That's what we're doing, but in three-dimensional space. So it's everything this way. So this would be like, you could say half the line. And this is like half the three-dimensional space. So that's where that kind of terminology comes from. 25. You know what? I think I'm going to have to run. What time is it? Yes, I do. Yes, I have to run. But let me just tell you what 25, 27, 29, what those answers are, and I'll let you try and figure those out yourself. For 25, there's really no way to do 25 other than to say that it's all the points where your z value, it's all points between two planes. The plane z equals 0 and the plane z equals 6. For 27, that looks a lot like a sphere equation. If it was an equal sign, it would be a radius of square root of 3, but it's less than or equal to, so it's actually a ball. It's not just the surface of the sphere, it's everything inside of it. So it's a ball of radius root 3, solid ball. And 29 is going to be a cylinder. That's a little bit more challenging, and I'll leave you to ask me about that if you have a question. We can talk about that another time. Well, you know what? I can do it real quick. X squared plus z squared less than or equal to 9. So if this said x squared plus z squared equals 9, this would be a circle, right? This would be a circle radius 3 in the xz plane. So imagine a circle in the xz plane, so like this. But it's less than or equal to, so it's actually a disk. And notice z doesn't appear in here. Since y doesn't appear in here, so y can be anything. It's never going to change this inequality. So if y was 1, does this change? No. If y was 10, does it change? No. So since y doesn't matter, it'll be this solid disk moved along the y-axis wherever you want. So what you do is you create this solid cylinder, this like rod, this bar. All right, that's all I've got time for. I'll try and do 10-2 as soon as possible.